Okay, with this one right here, we are asked to condense this all into one single logarithm. Well, I have some numbers out here in front. This one has a 1/3 here, and this one has a 1/3 as well. So that's going to be my first step in trying to condense this into one logarithm. So here's our rule that we're going to use here. The rule states that anything that's out front here can be converted, can be condensed, if you will, into the exponent of whatever this value is right here. So let's kind of look at one. I've got an x, a natural log of 4. Basically, this x, we can move it over and have it become the exponent for the 4. If we do that, it will look like this. Okay, so we're just going to take that number out in front and move it to the exponent. So I'm going to do that with mine down here. The number out here in front is a 1, so I don't need to really do anything with that. If we moved it over, it would just be y to the first, which it already is. So we're not changing the value there. So we don't need to worry about that one. But these have the 1/3. So if I move this, I'm going to take this 1/3 and move it around here. It will become the exponent for this x. And the same thing for this 1/3 for the exponent of that z. So it's going to look like this. Okay, so this one I didn't change at all. This one I just took the 1/3 and I moved it to become the exponent of this x. And same thing for this portion right here. Now we know what x to the 1/3 is. Anytime you have a fractional exponent, we can represent that in a radical, in radical form. Well, x to the 1/3 is the same thing as the cube root of x. And same thing with z. This would be z to the 1/3, which would be the cube root of z. Now, if this were, let's say, x to the 1/2, that would be the square root of x, or x to the 1/5 would be the fifth root of x. But since this is 1/3, it will be the cube root of x. So let's kind of simplify that just a little bit further here. And again, these two here are equivalent, okay? X to the 1/3 is the same thing as the cube root of x. Okay, well, now that we've got that, now we've got all of these, I need to move on now. Because of these addition signs here, we're going to use a different law of logarithms, which basically states that if it has the same base, and these are all base e, these are the natural logarithm, but the same rules apply for normal logarithms too. So they have the same base here. All we're going to do, if it's addition, is to multiply these two components right here. In this case, it's x and y. It becomes xy. So let's look at another example here. I have a natural log of 5 plus natural log of k. These have the same base. I'm just simply going to multiply these two together. 5 times k would give me 5k. And that's in the condensed form. Now I'm going to do that same thing here. Okay, so I'm going to have to multiply y times the cube root of x times the cube root of z. Now both of these two here are both cube roots, so they'll remain underneath the radical. And this y will just kind of hang out front. So here it goes. This is the natural log of y. Now this is not y cubed, but in this, so that gets a little bit confusing, but just make sure this is y to the first power times the cube root of xz. Okay. Now we always write the radical at the end, but y to the first power again times the cube root of xz.